Hi, welcome to the second video in the integration topic at Higher, looking at just some further examples of how to integrate. A couple of things we need to look at today: being able to integrate a string of terms by taking each term in turn, and being able to integrate more complicated terms by first rearranging, so making sure all our variables are rearranged to appear in the numerator, and making sure all our variables are written in an index form. Now, I'm hoping you notice here by looking at the success criteria, this is very similar to differentiation. Okay, we can't differentiate without having all our fractions, all our x's off the bottom, and we can't have roots and cube roots, etc. involved, so we need to get them into fractional powers. It's exactly the same thing here. The only thing is, after we have completed the rearranging, we're not differentiating, we're integrating. Okay, so just a couple of examples. Firstly, we're going to integrate 4x to the power 7 plus 3x to the power minus 5. Now, just to note, first of all, these brackets here, they're only there so that everything is just basically math admin. Okay, so everything is getting, and everything inside the bracket is getting integrated with respect to x. Okay, there's no rearranging required. Okay, we've just got a string of terms to integrate. We're going to do it one by one, just like we would do in differentiation. So 4x to the power 7 becomes 4x to the power 8 divided by 8. Then we've got our second term, which is 3x. The minus 5 increases to minus 4, and we're going to divide by minus 4 as well. And again, we don't know if there was a constant, so we're just going to put it in a plus c. And then just tidying up, 4 over 8 just becomes a half, so it's x to the power 8 over 2. This whole fraction here will be negative now, so it's minus 3x to the power minus 4 over 4 plus c. Again, the x to the power minus 4 can come back to the bottom to rearrange, but that's integration process is completed. Okay, the problem with b, however, is that we don't have it ready to integrate. We've got a g on the bottom, okay, and we've got our root in here as well. Okay, so we need to rearrange that first. So this integral is going to become, well, when that g cubed comes to the top, it just is g to the power minus 3. And then that g to the power, the fifth root of g becomes g to the power of fifth in exactly the same way we did preparing for differentiation. Now, I'm going to put brackets around that all, and I'm going to integrate that with respect to g. So this is just my admin task, and that dg and the integral need to be there. Now I'm ready to integrate, so it just becomes an equals. 2g minus 3, that minus 3 increases by 1 to minus 2, and you divide everything by a new power, so divide by minus 2. Then we're doing minus g to the power of a fifth plus 1, so adding on 5 fifths, so it's 6 fifths divided by 6 fifths. Again, we don't know if there's a constant, so we're going to pop that in at the end there. Excuse me a second, sorry, I'm just going to put this along, give me a bit more space. Okay, and then that means just tidying up. 2 divided by minus 2 is just minus 1, so it's going to be minus g to the power minus 2. Dividing by 6 over 5 is the same as timesing by 5 over 6. So it's there. And what I'll do here is just put the fractions back in. So it's 1 over minus 1 over g squared minus 5, the fifth root of g to the power 6 over 6 plus c. Okay, so you can see that it can look quite complicated, but again, it's just the same processes. Making sure your fractions are on the top, your variables are on the top, so that g cubed there goes to the top, making sure there's no roots of any kind, and then you can rearrange it back just the same way. Okay, one more example just to go through, and we've got one of our fractions all joined together here. Okay, we know that we're going to unravel that fraction to make single terms. So first thing I'm going to do is do both those numerators divided by the y on the bottom, so split up my fraction. Okay, and I'm going to integrate that, all with respect to y. That first fraction, y squared divided by y, just becomes y. The second thing just becomes 3. Okay, so that is me ready to integrate, good to go. Y, well, that's y to the power 1. Raise that by a power is going to be y squared divided by a new power, which is 2. And then you're going to have 3, just the same way that if we are differentiating, I'll do a little thing. If f of x was equal to 5x, f dash x would just be 5. So we've got a number going backwards, it's just going to end up being 3y. And again, constant of integration in again. Okay, so you can see there's not much difference here. No new ideas really, it's just putting together that old idea from differentiation about having to be arranged first alongside our integration that we've done so far. Okay, so being able to integrate a string of terms by taking each term in turn, yeah, just doing them one by one. Excuse me, sorry. Okay, sorry about that. So being able to integrate a string of terms by taking each term in turn, remember that if there's brackets there, a lot of the time it's just so the dx applies to all, and then being able to integrate more complicated terms by first rearranging. So being able to rearrange the same way we did in integration, differentiation, sorry, by bringing things to the top and getting rid of square roots and etc. Okay, so thank you very much for listening. Bye. Bye.